In this problem, we're asked to find Vs if V2 is 220 at an angle of 0 degrees, volts RMS in the network below. And if we look at our network there, we've got a load represented with a complex power. There's a two-port network that's described by a set of transmission parameters. Then there's an ideal transformer, so we're going to start and work our way through the two-port, through the transformer, and back over to V sub S. So to start, let's calculate. I'll define this current Ix. Let's calculate Ix, and to do that, we'll need to calculate the complex power for the load. So S for the load has a magnitude of 10. The angle is cosine inverse 0.8, and it's positive. It's going to be in kVA. So this is 10 at an angle of 36.9 degrees kVA. Now, S load from our diagram is V2 Ix conjugate. So we can solve for Ix is S load over V2. Take the conjugate. So we have 10 at an angle of 36.9. That's kVA. I'm going to put the voltage in kV. So Ix is 45.45 at an angle of minus 36.9 degrees amps RMS. So we can see from the diagram that I2 is a negative Ix. So that's minus 45.45 at an angle of minus 36.9. And if we move the minus sign in, we can do that by adding 180 degrees to the phase. There's I2. So now if we look, then we know I2 and V2. Now we can use our transmission parameters given here to find V1 and I1. So V1 and I1, we take the transmission parameters, and then we multiply by V2, which is 220 at an angle of 0, and then I2 is 45.45 at an angle of 143.1. So if we go through and calculate, V1 turns out to be 382.7 at an angle of 41.77 degrees volts RMS. I1 is 45 at an angle of 61.9 degrees amps RMS. So now we know V1 and I1, and we're ready to go through the ideal transformer. And let's call this voltage VA, and let's call this current IA. And if we note that we have both currents entering the dots, okay, and if we remember back from our chapter on the ideal transformer, that when that's the case, what we'll have is we'll have 5IA is equal to minus I1. Okay, so we've got both currents entering the dots. So then IA is minus 1/5 I1. So IA is minus 1/5 times 45 at an angle of 61.9 degrees, and that's 9 at an angle of minus 118.1 degrees amps RMS. Also, if we look back at our circuit, our two voltages are not referenced, both not referenced at dots. And if we go back to our transformer chapter, then what we have is VA over 5 is equal to minus V1. And that's again because one voltage is referenced positive at the dot and the other one is referenced positive at the undotted terminal. So then VA is minus 5V1, which is minus 5 times 382.7, angle of 41.77. So VA is 1913.5 at an angle of minus 138.23 degrees volts RMS. Now, to find VS, all we need to do now is apply KVL around that loop. So, VS is 1 plus J2 times IA plus VA. So we have 1 plus J2 times 9 at an angle of minus 118.1 plus 1913.5 at an angle of minus 138.23, and that gives us VS is 1915.86 at an angle of minus 137.63 degrees volts RMS.